Okay, guys, my name is Marc Korthaus.
Really?
And I'm the founder of and CEO of Syseleven. We are a hosting provider. I did a site regarding Macintosh news. We had problems with the keynote stuff from Apple, where each user want to see what Steve Jobs is presenting as a next toy. So we didn't have the money to buy as much servers as we needed, so we needed to go into the application stack and optimize it. That was the birth of Syseleven, and that's where we today are here. Why? Because we know how to fasten up applications on the server side and on the application side, which probably is your case, but anyhow, it should fit. Did someone of you know where this quote comes from? The first beer is on me, whoever gets it.
Murphy's Law.
That's Murphy's Law, right. That's the original version of the Murphy's Law. And you know, it's true. Okay. Why a hosting company? I just mentioned it. What we did, we hadn't much money to buy as much iron as we needed that time. So the only way to deliver the site while we had these amazing traffic amounts running to our data center, the only way was to optimize our application. So what we do is we asked some guys, and could you help us? Didn't work out. So we did it on our own. Strict budget was a great school for us. So pressure makes diamonds. We learned a lot, and this was why I'm standing here talking about scalability and talking about performance. So while most people are getting this mixed up together, it's two completely different things. Capacity, which is another word for scalability, is what you have in mind by adding servers and having more capacity to handle the same load. So you don't have a faster site, but you have more users using it. Google won't be faster with a more application, but you need as much servers to handle the amount of users. While performance is the application side on it. So yeah, what you can do is you optimize for time to first byte. You can buy more hardware power, but normally the most sufficient way to have a speedy application is within the application itself. So, which brings us to the point where capacity is what normally the hosting company is doing, and the performance side is yours. That's the traditional way of looking at our business or our industry. But you all know that's not true, because it's always mixed together. What kind of machine I'm using, how do I use it, how's the architecture of my application, and how does it all fit together, especially if I have a lot amount of traffic to handle. So what you do is you go to the Magnolia site and have a look what exactly they are talking about the server setup. You go to this part. You all have seen this, I guess. You go for the clustered version with this slide, and that's great, but it's only a start. We do a lot of e-commerce applications, and since they have transactional business and there's money depending on how they deliver their site, even if they have TV spots or mailings or whatever, it's and the content normally is not static; it's individually rendered. We go with a setup like this one here. So in the first place, you have a hardware load balancer. You have a front-end cache, which in this case is an NGX configuration with an internally used Couchbase as a memcache bridge. You also have an API for your cache. You have the application servers, which would be, in this case, a Magnolia application server. This is we do have customers with a lot more machines, but anyhow, normally that's the PHP guys. So you're on the good side. In this case, the customer has a database master which is on MySQL, which doesn't work pretty good with master-master replication. You could use it on Postgres or on Oracle or something, but I guess all of you guys using MySQL, right?
Nope.
No! What are you using? Postgres. Ah, that's okay. I like it. Both. Ah, good. So, you have a lot of DBS slaves. Recently, we had a patch for the common e-commerce applications to handle reads from the slaves and writes to the master. You can patch only the database driver, which is more efficient than having something like the ugly MySQL proxy in front of it. But however you do it, it should be handled by your application. If you can handle it within the application itself, patch the driver. These customers, I haven't seen it on the CMS space, and I talked to a couple of guys the last few days. Nobody of them mentioned the opportunity of having a search engine configured for the websites, which is quite common in terms of e-commerce applications. You also have shared storage, which is something you could add, but probably you only use it as in some parts of your application. But especially with Magnolia, it's you have to use it in some terms. You have some administration tools where you can have log processing, Kibana, Splunk, whatever your hearts fit. And you have a recommendation engine. So this brings us to the term, how does the traffic goes through this kind of server setup and how it is grown to this size. But first of all, let's talk about a little bit about what you can do about performance. How to improve performance. You normally go with the bigger machine, but that's the most expensive way. You can add CPUs with a higher frequency, which is even more expensive, because the top line of the manufacturer is normally the most expensive. So you get a little more performance for a lot of money. I don't expect you guys to do it. Same goes with SSDs. There are a lot of consumer SSDs in servers right now. If you buy something from whatever hoster, you will probably get not enterprise SSDs. So I wish you good luck with it. But anyhow, it helps in terms of I/O frequency. So you normally go with optimizing for the time to first byte, because you never know where your users are located in terms of latency of the network. You also have to tune your database. I never seen this so far in the CMS space, but a lot of customers really needs to get their database queries in running, because normally scheme isn't right. They use the wrong database engine. They don't have indexes set. Whatever, we've seen it all. So you have to normally you have to tune it, and it's per release you have to tune it, because a new feature comes in. You have to tune it again to handle all the load, because as you remember, you only have one database master, and he's a single point of failure. You can automate to fail over to a slave and make them to the new master, but anyhow, you only have one in the first step. And we just recently talked about how you can profile your applications to know what's internally happening within your application. While they are all kind of profilers, the New Relic guys here are more like a service. So they render it how your application performs week after week after week, or month after month. While the AppDynamics and Dynatrace are more than not a service itself, but it's more like you can profile one application after another. So let's talk a little bit about what could really help. That's caching. I will come to this later. And since I talked about performance, I have to talk a little bit about scalability, but which isn't a lot. Don't be shy. Jackrabbit is the way you already knew and have read and probably done yourself a lot of times. Big Iron is, I like Big Iron, it's great. It's expensive. Nobody else buys it. It makes fun to use. I go with big iron, but you know that's quite expensive. So you probably, even if you rent it, it's a lot of money, and you can spend it on a lot more things than big iron itself. So have you ever tried using the standard NFS kernel driver from Linux? Someone probably have tried using it. Okay, you tried? You stopped, I guess? Okay. It didn't work out, yeah. Same here. So you have to buy the big iron. There's it again. Database clustering. There's a new feature coming up from the Galera guys, which allows you to use MySQL as a master-master database. We do have internal tests about it, and a lot of customers try to use it right now. So there will be a solution to have master-master replication on MySQL in the next couple of months, but that's very an early stage. So who of you knows what's sharding? You know? What is it?
Cutting up your data in parts and not
Exactly.
all data everywhere.
That's right. So that's what the most prominent user which used it is Facebook. So a couple of thousand users goes per MySQL cluster, and after the next couple thousand users comes on another cluster, and they live within one cluster near the city they live. So what's even important is elasticity. You probably have one TV spot running, and a couple of times days later the next campaign. So you don't need the full hardware for all the time, and you don't have to rent it for like 24 months or something. So you would like to have elasticity. The DevOps stuff. Who of you is actively using DevOps strategies to deploy their applications? But you all heard of it, right? And who want to make it within the next 12 months? Nobody. Okay. There's one. You're the guy. Okay. So it's about how agile you develop and how agile you get your code delivered to your servers, preferably without any without doing it by hand. So we use Puppet for it, and a lot of our customers going with Chef. And on the Java side, I don't know if you already learned about it. Go recently got open sourced, so with your own Ant scripts, you can develop your own DevOps environment. So if you're interested, just step by after the presentation. So these are what I urge you to understand. The only way really to fasten up your application is not to throw iron about it or add it, but to cache within the application, outside of the application, and within the server framework itself. So you all know the eCache or EH cache. I don't know what's the right proposition in English for it. You know? EH cache, okay. I go with that. Okay, thanks. You all knew it. I just asked in front of the at the beginning of the presentation who's using it. It's in Magnolia itself, so good so far. Just use it. You probably heard about Varnish. Varnish is a full-page cache. In the first at the first look, it only caches full pages. It supports ESI, but there's no advanced flushing via API or some other stuff. So it's great if you have a full page in one cache outside of your application on a different level of servers. And you can scale it by having more of them and load balance them. But as soon as you do, you have problems like there's one page is in the left-hand cache and the other page is in the right-hand cache, and it's fully mixed up where the next user will get the page from. So you have to feed your cache multiple times. And as many Varnish instances you have, and at least you should have 2 in terms of high availability, you probably have at least 2 times to fill your cache, which is probably a bad thing if you are in the middle of a TV spot or right after a failure. So if you just roll out your new application and you have version 3 running and not version 2 any longer, you have to reflush all your caches, and you have a slow start, which could be quite painful, especially if you don't configure the cache time per URL part, which means that parts of the application will be time out like after 6 hours. So what we learned with our customers was that after 6 hours the site was down. Nobody learned why is the site every 6 hours the site is down. So we learned that it's because the normal life size of the cache was configured to 6 hours. So every 6 hours it was completely flushed and it has to be filled up again. And at 8 in the evening, that's no good idea. So it heavily depends on when you flush the cache the first time. So when you flush it or have your deployment ready at 12 o'clock, you probably shouldn't have a lifetime of 6 or 8 hours for your cache lifetime. What you also can do is, if you have to restart Varnish, you probably have a cold cache, because it doesn't write down whatever it is in memory. It doesn't write it down if you restart or if you have to do a cold start because the machine just recently got whacked up. So, which is painful for the application. And we're talking about having really a lot of traffic in these scenarios. So what we developed, and since we are no developers, we are more like architects. We architect our solution, which has the wonderful name Supercache. So what we did on the Supercache is we separated at first memory and delivery. So you can have our own Couchbase, which is Memcache compatible backend in your load balancer, which handles the traffic exactly like a load balancer do. So it asks the memory backend, which is in this case a Couchbase cluster, which could consist of multiple nodes, which is a good thing too because it's highly available. You can go with you can scale each of these layers separately. So and you have an API developed that's in Lua scripted. So there's an external node which allows you to tag your content and recursive delete parts from the cache by their tag. I will show you later what this exactly means and how you can use it in your applications. And the best thing of all is you have an infinite cache lifetime, because since the plugin of the application or within the application, the API is used to flush parts of the cache or items from it, you never have to define a cache lifetime. Because it's in the cache, it's valid. If it's not in there, the module will put it in there. So how does the... this is the best one, sorry, I forgot to mention. We are in preparation and developing the module right now, together with Magnolia itself, so it will be part of some future releases. I think that's the good part. In the next slide, I will show you how it really works, because I guess it's in the first view, if you ever look about how your content goes through your application, that's complicated to understand. So we have a couple of servers. A load balancer, probably hardware, because you need some DDoS protection or whatever, or web application firewall within it. You have the proxy, which is in case of the Supercache is an Nginx plugin. You also have some scripts on Lua on how to decide which traffic goes to the backend and not. You have the Couchbase server backend, which is compliant to the Memcache API. So you can use it as a Memcache backend. Actually, it's not Memcache because that would be a single point of failure. It's 2 servers, and we have one customer which has 6 servers of it. and has defined a cache. N is 3 for him, so each item we put into the memcache memory will be on 3 nodes at least. So that's what you can do here. You can add as much nodes as you want. You can go with 100 GB of memory, whatever your design of the application needs. And you have the Magnolia application servers, and you all know what this is. So what happens if an HTTP request is coming through the application? It's going to the first load balancer, going to the proxy, that's the easy part. The proxy decides, do I have this item in my cache? And that's the first route the server, the request is taken. So it asks, do I have a hit? And if it's a hit, that's easy. It just pushes the thing, the item back to the proxy. So what happens if you don't have a hit? You have a miss. The proxy will learn that there is no item with the exact same URI, and will ask the application servers to provide the page. It will be rendered within Magnolia. It will get delivered back. So, but since it's not in there in the cache backend, what happens is a Magnolia plugin will take the rendered page and put it within the memcache cluster. So while it does it, it appends a tag. What is the tag? Everybody of you knows a tag could be everything. So it could be in an e-commerce application, it's normally the product ID. It could be the page ID. It could be an item ID of content, which could be part of the page which was rendered just a second before. This is important because you need probably to flush parts of the cache as soon as the authoring server will have one item changed. You have to delete all pages from the cache which includes these items. And that's why you need to be tagging your content. You need to tag the content ID or whatever, perhaps you go with your own tags. You just tag one content you put to the Couchbase server, and you have an API. I don't put it on the slide here, but there's an API this can run here or there. So you go again, if the content server just gets new content from some editor, it will put it into the Couchbase server, and it could delete it by tag. And that's the most important thing about it, because you normally go with you are looking for, and I don't know where Magnolia is standing in terms of e-commerce integration, but you all want to buy red pullovers. And you get one URI cache item which is a page which includes all red pullovers. So, but at some point, one red pullover will be deleted because it's out of stock. So what happens? The plugin here will delete the tag item, delete all pages that include this tag. It will be deleted here, and from there on, it has to be again fetched from here, where it doesn't belong any longer because it's just changed. So that's the most interesting part about this caching solution. It's active. You and your application is able to provide the API with the necessary tags to delete it recursively. So that's the idea behind the super cache, and that's the main difference between this this tool set for caching and all others I've seen. So what's in for you? Easy. You have a RESTful API you can use with your tags. It will automatically map your tags against the cache items and delete it recursively. I just mentioned it. You have infinite cache lifetime. You don't have to worry about how long a cache item will stay, because as long as it's in there, it's okay. It should be there, so even if you restart some of your services, you have a warm cache running. Because if you shut down Couchbase Server, it writes down its memory to the disk and reads it in afterwards. So perfectly. No cold cache ever. Couchbase Server can differentiate between disk and memory, which Memcache actually does not allow you to do. So you can talk about really big cache sizes, where you have hundreds of gigabytes of cache items, which probably is not the case for the most of the Magnolia instances I've seen. But anyhow, you can grow it beyond whatever, which could be interesting if as long as you go with videos. When you go with videos, you can define in Couchbase Server how often an item has to be retrieved to be not stored within memory. So you can define where the hot data will stay. It's DDoS proof. We are hosting a website called golem.de, which is one of the biggest IT news sites in Germany. And we just got a DDoS attack on them. That was, I guess, a year ago or something, where the anonymous guys were actively using their resources to use other people's resources. So what we did is we put a supercache in front of it, and since they never got beyond 8 gigabits of data, they were pushing out of the solution, we were able to fully run the whole site out of the supercache on 8 gigabits of pushing data. So, which is quite important because that's the scalability I'm talking about. Probably, who of your customers ever got DDoSed? So you lucky bastards. Okay, probably at some day it will come. It doesn't depend on how you design for being DDoS and handle these amounts of traffic, but it's important to know there are solutions which are able to handle it. And it uses, in this DDoS attack, it handled very high amount of traffic with only with 2 threads, so that's nothing. A normal CPU from Intel you can buy has at least 16 to 24 of them. So that's very not resource intense. So what's probably in the next couple of months or probably years going to be an interesting point is how you combine data or pages or parts of pages across different applications. So if you guys having a CMS backend as part of an e-commerce application, how does you handle it? Because parts of the page will come out of your CMS. Other parts, like the shopping cart, will be part of the page. But this definitely will not come out of Magnolia. So you have 2 applications, and both of them are in the need of delivering snippets or parts of pages where your application somehow needs to interact with it. And you can ask via API, please hand me over the shopping cart results and I will handle the data myself, because that's way too much load you're generating on it. So what do? You use ESI templates. What you do is you define snippets you can render within your proxy in the front plate, and both of them can have their own lifetime. Because the cache itself has an API, so you can put things into it, and you can render the whole page within the proxy, and you don't have to definitely running a REST call to the CMS application or the different way, which probably won't scale either. So that's an easy way to combine applications, which probably will be in the next couple of months and years, will be part of your work. So how do I integrate this kind of applications within each other? ESI could be one way, and you need a caching solution that allows you to handle it and each snippet and part of the page differently. So that's why Supercache probably is an answer to it. What you also can do, and probably none of you have ever done it, but you need to know that it at some point will be necessary, layer 7 manipulation. You need to set cookies. You need to set different HTTP headers within your applications because, as you've seen, if you have a lot of servers as the code is running through, or the HTTP request is running through, you need to set headers and implement tags within headers and stuff. So at some point, you will need HTTP manipulation. If you never done this, it's not as hard as it sounds, but it's complicated because it's hard to debug. That's why our customers normally have something like Splunk or Kibana as a central log solution where they can debug problems from a couple of servers into one instance. So the last thing I want to talk about, if you have these what the hell great caching solution, will each hit really hit the cache, or how many misses you will have? So the easy answer is there is no appropriate solution where you have a cache hit with each request. This is one of our customer. He's a lucky guy because 50% of his traffic will hit the cache. But the other 50% just goes through the application layer and will be with EH cache or whatever within the application be handled. We have a second customer which only has 13% hit hit rate. So why does this happen? It's so easy. Part of the identifier within a cache item is part of the URL, the URI, which is the complete URI. But if you have session information within your application, within your URL, you never will have a cache hit with it. Because as soon as a user logs in and you don't trust cookies, which is a good thing in the first place, then you probably have a cache miss on it. So you have to scale the backend again. This is what this customer is doing. He's someone who, for some reason, isn't able to provide unified URLs for all logged in or non-logged in users. And we have one customer. He's a really lucky guy. He's a lot of static content delivering, or he has included all his multiple application servers so that they rely on HTTP headers. That's why I mentioned the manipulation of it. And so he has a pretty good hit rate. Never underestimate the load which goes even on 50% through your application servers. Because even if it's a pretty good hit rate, you have to scale for the other 50%. So what do you need to do? You need to measure it. Because it doesn't work if you only rely on, oh yeah, I believe it's a good hit rate. It doesn't work. Just measure it day per day. And if you have more customers using a cache, just measure between them and compare and learn about it. So what are the most sufficient ways to ruin your cache hit rate? I already mentioned the session URLs. That's a good way. Also pretty interesting is a lot of A/B testing, because at some point you will deliver the site from a set of other applications, because your customer needs to know how which part of the application you are providing are performing the best conversion rates. And if you suck at implementing these, that's a good way too. You have a lot of content updates. So our customers partly integrating with Amazon, for instance. So if you're talking about a book community or something, that could be interesting, because you probably at some point have to import all books available on Amazon. So that's great. How many books Amazon have? Just guess. No, 100 million. Okay, That's too much. 1 million. Pardon? 1 million? Yeah. It's between both. Okay, it's around 7 million items, I guess. So, and you know, it's a book community lives if the content is. So there's a new book, and the next day you should know it. So you need a daily import of 7 million articles. So that's funny within Magnolia, I guess, right? Did someone try it? Okay, good luck with it. So, but you know, that's the problem. If you have a lot of stock changes or item updates or imports which change your content, even if you can handle the load, which is part of this process, you have so much content updates within your items in your cache, you probably have a bad cache hit rate. And there's a trend going on. I just mentioned before on the server setup from one of our customers, which is we don't deliver through a CMS. We don't deliver the product pages within the CMS the e-commerce application provides because they suck. We just use our product search to do it because you get an XML back from the search engine, so you can render it in your whatever application to have a nice looking page afterwards. So a lot of people just doing exactly right this. And that's what your prospects are probably deciding against in full-featured CMS. So they use something like, in this terms, it was Fact Finder. It could be Finder Logic, Search Metric, not Search Metrics. It could be Elasticsearch or Solr or Lucene-based stuff. It could be everything. So what they do is they import their whole data set of products within their search engine. It's clustered, so they can scale it out. And they have one application asking, as soon as you have parts of the URL looking for red pullovers or t-shirts or whatever, they doing a search within the search cluster, rendering it back to the application, which designs the layout of the site. And afterwards, it gets delivered to the site. So that's what some of our customers are doing right now, which is trending because it's faster than having a full-featured CMS or developing a CMS on their own. But in my opinion, that's an opportunity for you guys. Because if these both things grow together, e-commerce and CMS applications, that's where you guys can grow. And that's why I'm telling you there's a feature set which is part of some of the applications we have seen. So perhaps we can keep on the discussion with these kind of solutions, but I see growing it together because all CMS plugins for any shop systems they still suck. So I guess there's business for you, and I wish you good luck with that. So some numbers about how it could work if you do the caching right. You have an application. So 2 seconds is for a not as hot, even with the internal caches, sometimes data is not hot inside of it. So 2 seconds load time is pretty normal, I guess, for you guys. Oh, 2 seconds, 1 second, 3 seconds, something like that, right? What do you have?
0.4.
Oh, that's good. But not after the content, but only if it's a cache hit within EH cache, right? Okay. If you go with something like another cache I just mentioned, you go there, and this is where the super cache goes, because the way through it is way faster, especially after some time where all the Varnish stuff has to be warmed up again. So in the measurements we did, we purged it a couple of times, and we calculated the middle line of it, and there you go. I can discuss this further if you want to have some more numbers about it, because presentations suck for mathematical discussions, but anyhow, there you go. So, thanks for your time. I hope it was not too complicated, interesting, and somehow enjoying. So if you have some questions, hand it over to me. Okay. Thank you for your time. I don't know if I missed my deadline, but anyhow, thanks, and I'm enjoying having a beer with you in the evening. Thanks.